Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. We're only going to get 2 in because of the France trip and so forth, but we will get at least, well, not at least 2. Well, I guess at least 2, but actually 2. All right, bonus weather video number 2 for this week. And I thought it might be interesting to, and I think we did this a long time ago, but compare the position of the sun, how high it gets in the sky, and how long the days are as you vary in latitude from the equator to the North Pole. And I'm going to compare this on 2 dates, okay? One is going to be on or about December 21st, and the other one is going to be on or about June 21st. So basically, on December 21st, as far south as the sun goes, okay, and June 21st, on or about as far north as it goes. And how do things vary? Because the north has a bad reputation, you know, about it being cold in the winter and all that sort of stuff. But there is an advantage to being farther north between March 21st and September 21st. And we're going to talk about that in just a second here. So let me put myself down here in the corner and let's try to be fair about the North and the South and all of their respective advantages and disadvantages. All right. So, on or about December 21st, and the first day of winter varies from the 20th to the 22nd, I guess, but just for simplistic purposes, let's go with the 21st. So, the left-hand column there is the latitude, starting at the equator, 0 degrees north or south if you prefer, all the way up to the North Pole. And then the length of day is the middle column and how high the sun gets in the sky. In other words, the number of degrees above the horizon that the sun gets. So, at the equator, really, the length of day doesn't change a whole lot during the course of the year. It's, you know, very, very constant or nearly constant. So on December 21st, they have 12 hours and 8 minutes of daylight, and the sun gets about 66 2/3 degrees above the horizon. Now, you got to remember that the sun is directly overhead at 23.44 south latitude, okay? So if you're at the equator, then you simply subtract 23.44 from 90, okay, and then you get 66, well, 66.57, 66.56 in that same neck of the woods, okay? So it gets about 2/3 of the way up to being directly overhead. By the time you get to 30 north, which is south of Raleigh, we're at about 36, the length of day is 10 hours and 10 minutes, and the sun only gets to about 37 degrees above the horizon. By the time you get up to around New York City, they've only got a little over 9 hours of daylight, and the sun only gets to 26.59 degrees above the horizon. By the time you get to 60 north, which is not quite to the Arctic Circle, but getting close, they only have 5 hours and 54 minutes of daylight, and the sun only gets 6 degrees above the horizon. And then once you get to the Arctic Circle and points north on December 21st, it is total darkness, okay? And so when you see those minus numbers on the sun elevation angle, that's the number of degrees below the horizon that the sun is in the middle of the day, okay? So from the Arctic Circle north, it is constantly dark, you know, 24 hours a day on December 21st, and then slowly things start to improve, but even at the Arctic Circle, there's still at least 1 or 2 days that are completely dark all the way up until about the 21st of March, okay? And, you know, there's been studies done about, I remember when I went up to Barrow several years ago, the suicide rate gets really, really high up there when, you know, they're totally dark, I think from late November until late January, something like that. So can you imagine it being just dark all the time for 2 months? You know, that'd be a little tough to take. And then on top of that, it's bitterly cold and snowing half the time. All right, so now let's switch gears and go to June 21st. And, you know, the first day of summer this year is on Thursday, June 20th. So this is only 1 day different. So notice at the equator, 12 hours and 8 minutes. That hadn't changed at all, and the sun is 66.57 degrees above the horizon. And that's because now the sun is directly overhead at 23.44 north. So it's sort of overshot being directly overhead, okay? And now it's still the same amount above the horizon, but it's on the, I guess, the other part of the sky. Now you get up to 30 north, which again is just south of Raleigh. Notice what's happening to the length of day as you head north. It's getting bigger, okay? And so at 30 north, you've got 14 hours and 5 minutes of daylight, and the sun is not directly overhead, but within, 6.5 degrees of being directly overhead, 83.44. Up around New York City, they've got 15 hours and 1 minute. And up around 60 north, they've got almost 19 hours. And once you get to the Arctic Circle on June 21st, it is light 24 hours a day, okay? And so from March 21st to September 21st, the days get longer as you head north, okay? So that's why I wanted to be fair about the north. There actually is an advantage to that. So if you think about this here, not only are the days getting longer as you head north, but also the sun is getting higher and higher in the sky, okay? So this is why the amount of temperature contrast from Canada to the tropics gets less in the summertime, because instead of getting no daylight at all at the North Pole, they're getting 24 hours of daylight, although it's at a very shallow angle, admittedly. And of course, they're getting it continuously, as opposed to at the equator, where it's only about half the day. And so they make up, for the fact that during the winter months, they're not getting anything at all up there. So the amount of temperature contrast decreases from north to south, and that means the jet stream, which is driven by temperature contrast, is much, much weaker, and we don't get the big storms rolling across the country the way we do during the winter season. It's more of these, thunderstorms that pop up in the afternoon and evening because of heat and humidity, but you don't have these big storm systems, okay? But now let's talk about, if we go back here to the wintertime, you're not getting any daylight at all north of the Arctic Circle, but the equator, the sun is still very high in the sky, and they're getting, 12 hours of daylight, okay? So it's still very warm in the tropics. It's getting very, very cold up in the Arctic region. And so the temperature contrast is increasing from north to south. The jet stream is getting stronger. And as a result, we start to get storms moving across the United States with a lot more vigor, with rain and snow and high winds and all that kind of stuff. So I just think it's interesting to sort of look at, and by the way, the latitude I kept constant for both of these tables. It was at 80 degrees west, which is about where Raleigh is. It's 78.8, something like that. So it's awfully close to 80 west. So I just took a longitude line and just kept moving the latitude up along that longitude line. So from March 21st to September 21st, there is an advantage as you head farther north, with the days getting longer and longer and longer. And then, of course, from September 21st until March 21st, they get shorter and shorter and shorter the more you head north. So half the year is an advantage, half the year is a disadvantage. All right, folks, that's it for now. That's bonus weather video number 2 for this week. Hope you have a wonderful Friday evening and even better weekend. We'll catch you again on Monday. Take care, everybody.